Alright, so this was June 2014, question 8. What do you think of this one? This is hard, isn't it? This is why I've chosen it, okay? I tried to choose 2 reasonably difficult examination questions. So if I just talk you through them, you can kind of fully understand what's going on, alright? So let's have a look. So I've got point A, sorry, vector A and position vector B there. Line L1 passes through A and B, find the vector AB. So it should be quite easy to begin with. So I'll tell you what, let's write it up here, shall we? So AB is equal to, what's that going to be? 1, -1, 1. Okay, that's part A done. Let's just get rid of that. Part B, hence find a vector equation of the line L1. Okay, so the line L1 has got to be, well, it goes to points A and B, so choose either of those points for your position vector. So I'm going to go for that one. -2, 4, 7. And then what you need is lambda times by your direction vector. The direction vector is AB, so it's that 1, -1, 1. So that's it. That's part B done. The point P has position vector 0, 2, 3. Given that angle PBA is theta, show that cos theta was a third. Diagram time. Okay, diagram time. So just draw a quick sketch. There we go. It doesn't matter what it looks like. Okay, so that's theta. Now it's angle PBA. So B must be in the middle. Okay, so PBA, let's just put P there and A there, shall we? Okay, so there you go, PBA, you agree with that? So show that cos theta is 1/3. Okay, now in terms of what we know, we've got AB is that then, isn't it? A to B is that direction. Now, remember what I said about scalar products, okay, and acute angles and obtuse angles? Because cos theta is a third, that means theta must be between 0 and 90 degrees. It's an acute angle. And when that happens, the vectors either go towards the point of intersection or both away. Okay, that's really important, okay? So because it goes towards, what that means is we need to know what vector PB is. P to B, okay? And P to B, so P is that, B is that, so it's going to be 0, subtract 1, -1, 1, and then 5. Let's check I've got that right. So P, -1, and then 1, 2 is 3, 5 is 3, so yeah, okay. So scalar product is next. When we said anything to do with angles, use a scalar product, okay. So it's between AB and PB, so you're going to have 1, -1, 1, dot, -1, 1, 5, okay? So that's going to be equal to, oh, that's in the way, isn't it? Let's put it under here. That's going to be equal to, so √3, and then root 25, 127, cosine theta. And I think there I could put in the 1 times -1, -1 times 1, and 1 times 5. So that's 3. So we have 3 equals that. Do you agree? Of course you do. So 3 equals √3 times by 3 √3 cos theta. Okay, so you have 3 is equal to that, 9 cos theta. Cos theta is 1/3. Okay, that's that bit done. The line L2 passes through the point P and is parallel to line L1. It's getting a bit, yeah, get a bit more, shall I use the word complicated? Yeah, I'll use the word complicated. It's getting more complicated than that. So let's just rub this off, shall we? I've kept that sketch there. Okay, let's introduce line L2. Let's recap what L1 is. So L1 passes through the points A and B. Right, so that is the line L1, isn't it? Passes through the points A and B. L2 passes through the point P and is parallel to L1. See how the diagram's making it really useful? So because L2 is parallel to L1, it's got to look like that, isn't it? So that's my rough sketch. So L1, L2 parallel passes through P. Okay. Find the vector equation of the line L2. Okay. So for L2, this could be R equals, find a point that it lies on. It lies, point P lies in line, so it's 0, 2, 3. 0, 2, 3. Use a different letter because we've used lambda there for that line, so use a different letter, mu, and you just need the direction vector. It's parallel, which means it's going to be having the same direction vector as that. Remember, that's the direction vector of the first line. That tells you what direction is. So parallel means it's going to have that direction vector 1, negative 1, 1. Okay, so yeah, that's how the diagram just made it so much simpler. Okay, the points C and D both lie on L2. Okay, AB equals PC equals DP. Oh. Okay, so AB, yeah, equals, we can treat those as vectors, okay, because it says C and D are somewhere on there, so that means is points C, D, P all lie in that line, don't they? So we can treat that statement as a vector statement. AB equals PC equals DP, okay, there's P there, okay, so if I just do A, B, P, C, somewhere there, so that looks about the same, doesn't it? And then somewhere there, so I'm going to exaggerate a little bit because I'm reading ahead to part F. Sometimes reading ahead makes it helpful. Reading ahead, it says that this is going to turn out to be a trapezium. Okay, right, trapezium, A, B, C, D. So look, if the trapezium is A, B, C, D, it's got to be A, B, C, D. Yeah. So I'm going to put there to A, B to C. I mean, I said P, C then, and then to D. Just that. I don't really want to put D there. I'm just going to extend it a little bit, just to make it look a bit more obvious, like a trapezium. All right. Okay. Yeah. Yeah, it's fine. Okay. Maybe if I just adjust this slightly, okay, to make it look a bit better. Let's just rename that L2. Okay, and let's put P right in the middle of that, because when you agree, P has got to be right in the middle of that. Okay, yeah, because just read it again. If it says PC equals DP, PC equals DP, P's right in the middle of that, isn't it? Okay, so there's my trapezium that I've got. Okay, so we're going to find the coordinates of C and the coordinates of D. Right, okay. Do I need to use that line there, find the equation of line L2? Don't think I do really. Okay, don't think I do really. I don't think I need to use that. That's just another question there. Okay, so what I'm going to do is I'm just clear my board a little bit, mainly while you think about it. I'm just going to rewrite some stuff. So PB, that was negative 1, 1, 5. Okay, let's write the position vector of P as well. That was 0, 2, 3. Okay, let's go. All right, so P to C. We're told that that's going to be the same as A to B, aren't we? Yeah, so it says that AB equals PC, but because those lines are parallel as a vector, you have AB is equal to PC. Yeah. Now AB is that, point P is that. Okay. So starting from P, if we then go forward that vector, we should end up at C. Does that make sense? Okay. So P must be 0, 2, 3. P to C is the same as A to B. So starting at P, if we add on AB, then that's going to give us what C is, yeah? So C is going to be 1, 1, 4. And somewhere it says the x coordinate of C is positive. Well, great. It's worked out well for us. Okay. What else? We're going to work out D. Right, so we're also told that DP, yeah, is equal to AB as well. So DP, let's write it down, is equal to AB. So we do a similar thing with that, except I kind of want to start off at P. So what that means is that PD must be equal to BA. Yeah. And let's just write down what BA is. It's just the negative of that, isn't it? Negative 1, 1, negative 1. Okay, so I've done it that way around because I want to start off at point P again. Okay, so point D is going to be P, which is 0, 2, 3, and then plus BA, which is going to be negative 1, 1, negative 1, and that's going to give me negative 1, 3, 2. Ah, can you see the x coordinate there is negative? Okay, so that's just in case for some reason you worked it the wrong way around. It's kind of telling you that out of your two vectors, because C has got the positive x coordinate, it's that one there. Okay, so yeah, anyway, that's C and that's D. Okay, next, find the exact area of the trapezium ABCD. Remember I said reading ahead, you know it's trapezium. Find the area of the trapezium. While you think about that, I'm going to clear my board and just rewrite the important bits. Okay. Right, think it through. So what am I going to put? So I've got yeah. So let's just put C there as 1, 1, 4. Let's put D there as negative 1, 3, 2. Okay, I don't need any of this anymore. Yep, okay. So remember how to find the area of a trapezium? There's only one formula for it, really. It's half A plus B times by H. Okay, so the area of the trapezium is 1/2 A plus B H. So we want to know that length, and the height. Let's do the easy ones first. So that length and that length. AB, it's like that's the length. So I've got the vector AB there, thankfully. Okay. Thankfully, I could have worked out again using that and that. So the magnitude of AB is to be root 1 plus 1 plus 1, so root 3. Now, magnitude of DC, I've done it that way around on purpose because like as a vector AB and DC, you can say CD or DC is length. That's either way, okay? Can you just write down what that is, or do you have to work it out? Okay. Let's read again. It says PC equals DP. Now remember when I said that, PC equals DP, I did say that P is right in the middle, okay? And it also says that each of those is equal to that. So that means is that is double that length there. So it's 2 root 3. You can verify it if you want. Okay, so look, that's C, that's D, so difference between them, so that's going to be negative 2, 2, negative 2, okay, so 2, 2, 2, so Pythagoras' theorem, root 4 plus 4 plus 4, which is root 12, which is 2 root 3. Okay. Sometimes it's a good idea to check these things, okay, even if you're expecting it, just check, because it's kind of verified for me that those are really likely to be correct, okay. So that's the easy bit, A, B and D. C. We're going to work out what the height of that trapezium is. And this is where most people get stuck. Okay. There has to be a reason, looking back through the question, as to why we were told about that angle there. Yeah. Okay. They've not just put that in just for the sake of, you know, look at this. Okay. They could have been a bit nicer. They could have asked her to work out the angle. They didn't. They said show that cos theta was a third. Right, so what we have to do for the height is this. Okay, here's a bit of trigonometry. Okay, so if I just put in a right angled triangle there as best as I can, call that the height h. We've got to work out that distance there using that angle. Okay, and what other length do we need with trigonometry? Well, if you've got that length and that angle, we either need that length or that length. Which of the two seems more likely, that length or that length? Of course it's that length, isn't it? BP. Because look, you've got B and P there. Yeah. So let's just write down what BP is as length. BP, tell you what, down here I'm going to write down what P is as a vector, B to P. So it's going to be 1, yeah, and then negative 1, and then negative 5, yeah. So that means the magnitude of that is going to be root 25 plus 1 plus 1, root 27. 3 root 3. So let's write 3 root 3, it's nice, wasn't it? 3 root 3. Remember, it does say work out what this is as an exact answer, simplified, and I've just noticed the root 3, so it's going to be nice if I put the root 3 there, isn't it? So that's what the length BP is. Okay, now how do we work out what H is? So trigonometry, so that's going to be sine theta. It's a pity you had to use sine, isn't it? Cosine would have been better. Okay, but I did say it's a challenging question. Okay, so sine theta equals opposites over hypotenuse. Okay, so that. All right. Now what is sine theta? Okay, well earlier we had that cos theta, let's write it down here, is equal to 1/3. And just check that. So this is another niceness of the question, okay? Even if you couldn't do part C, you can use that fact to help you here. Yeah, cos theta is 1/3. So sine theta must be root 1 minus cos squared theta, which is root 1 minus 1/9, which is the square root of 8/9, and then root 8 is 2 root 2, and root 9 is 3. Okay, so that's sine theta. Okay, so here we must have h is equal to 3 root 3 multiplied by that 2 root 2 over 3. Okay, and that's going to be 2 root 3 root 2. So let's call that 2 root 6, shall we? So h equals 2 root 6. I'm going to regret that, I'm sure. No, I'm going to keep it as root 3 root 2, okay? Why do I want to keep it like that? Because, like I said earlier, I've noticed all the root 3s, and I just want to make sure that it's easier when I do the final calculation. Right, let's give it a go then. Let's work out the area. So 1/2 a plus b. That and that, wasn't it? So that plus that. Let's write it down. Root 3 plus 2 root 3 multiplied by h. That's going to have to go. And we've got h as 2 root 2 root 3. Okay? Simplify this a little bit. So the half times 2. Root 3 plus 2 root 3. So that's 3 root 3 multiplied by root 2 root 3. Yeah? Root 3 is 3, times by 3 is 9, 9 root 2. And that's our exact area. Okay. Yeah, challenging question. Okay. But if you've understood it all, then you know what, you're well on the way to understanding vectors, which is a really good thing. And of course, you know, the whole point, the objective of me doing this. Okay. Hope you enjoyed that.